For 20 years, aviation security has been defined by what we can see and touch. We fortified cockpit doors and locked down terminal access to keep physical threats away from the aircraft. This strategy operates on an aging assumption that keeping the machine physically secure is enough to ensure the flight is safe. But the airliners of 2026 are not just mechanical transport, they are distributed computing systems. Every flight involves the processing of terabytes of data, shared between the cockpit, ground control, and satellite constellations. To function, these systems require constant, high-speed data exchange. Even when the cockpit door is deadbolted, the aircraft's digital interfaces remain active and reachable through the airline's network infrastructure. Because the aircraft is now a node on a global network, the nature of hijacking has shifted. A flight can be compromised without a single person ever breaching the cabin. It doesn't need to be boarded, it only needs to be updated. Consider a routine stop at a major hub like Frankfurt. In the 90-minute window while passengers board, the aircraft enters its most vulnerable digital state. Ground crews use GateLink, a high-speed wireless bridge, to sync the aircraft's avionics with airline servers. It functions like an airport's Wi-Fi, but instead of streaming video, it's uploading flight plans and engine patches directly into the plane's brain. An attacker exploits this bridge by phishing an employee, establishing a backdoor into the flight operations server. They inject malicious flight plan instructions, modifying waypoints and altitude data. Because GateLink is automated, dozens of aircraft download these compromised instructions simultaneously. When the crews power up for departure, the errors reveal themselves. Systems trigger conflicting navigation alerts and safety warnings, grounding the fleet before the first engine starts. By weaponizing a routine maintenance update, an attacker can paralyze an airline's entire ground operation without ever touching a piece of hardware. Once the plane reaches 35,000 feet, the digital attack surface expands. The plane leaves the local airport network behind and connects to global satellite constellations. This is where GPS spoofing becomes a threat. An attacker broadcasts a fake navigation signal that is stronger than the legitimate satellite feed, tricking the aircraft's computers into locking on to a false set of coordinates. The geography of the Black Sea corridor illustrates the danger. In this congested airspace, a spoofed signal tricks a plane into believing it's in international territory, while actually drifting toward a restricted military zone. This is a simulation of the cockpit display during such an attack. The instruments report a stable, trusted path shown in green, but this masks the true physical trajectory of the plane, which is diverging into dangerous airspace. Pilots are forced to immediately drop out of automation and manually cross-check their position using raw radar and inertial sensors. It's a massive increase in cognitive load during the most critical moments of the flight. The goal of mid-air spoofing isn't necessarily to cause a crash. It's to erode the crew's trust in their own data, turning the cockpit into a room of conflicting mirrors. Even as the flight descends, the aircraft is still talking. The engines are constantly streaming internal health data back to the manufacturer. This is called predictive maintenance. To prevent future breakdowns, engines transmit a real-time stream of oil pressure, vibration levels, and temperatures via satellite to maintenance hubs on the ground. On this telemetry dashboard, you can see how the system reacts to a data injection attack. By sending faked temperature spikes and oil pressure drops, an attacker tricks the aircraft into believing it is suffering a catastrophic engine failure. These faked failures trigger mandatory emergency landings and automated fleet-wide groundings. The attacker uses the airline's safety protocols as a tool for economic sabotage, costing millions in a single afternoon without breaking a single mechanical part. Global aviation is an interconnected ecosystem of aircraft, airports, satellites, and cloud providers sharing constant data. This connectivity creates vulnerability. Software certification requires months of oversight, but cyber attackers deploy malicious code in days, moving much faster than regulations. Commercial flight is still remarkably safe, but the definition of that safety is changing. The next major aviation crisis will not likely start with a mechanical failure. It will start with a quiet line of code.